Greetings and welcome to my new calculus channel. My name is John Gabriel. So as you all know, in the previous video I discussed a couple of definitions of book 7 of Euclid's Elements, and I'll be continuing from definition 5 and seeing how far I can go today. I'm not going to go too far, but just maybe a couple of definitions or more. We'll see. So let's begin. Now remember, Book 7, as just a recap, is a transition to algebra, okay? And the transition is done through the abstract unit. So definition 5 tells us that a number is a multiple of a lesser when it is measured by the lesser. What that means is that if P is a multiple of Q, then P divided by Q leaves no remainder, okay? That's what it means, really. And once again, there's no use of the word and, as you see in Heath's translation, anywhere in the Greek. So this definition is mentioned just in case you missed the concept of multiple in Book 5, okay? Because that's where it was first defined, right at the beginning. In order for a number P to be a multiple of Q, it must be the case that Q measures or divides P exactly, in which case it follows that Q is a factor of P. Now, definition 6 says an even number is 1 divided in half. That's not an accurate definition, and it doesn't mean that in the Greek, okay? So let's just see. A better definition, by the way, would be a number that has a factor of 2 or is a multiple of 2. But let's just see what the Greek says. It says the expression díχα διαιρούμενος was understood by the ancient Greek to mean fork into equal parts, of which each is a multiple of the unit, okay? That would be more accurate there to say of which each is a multiple of the unit. So Heath missed the context entirely in this series of definitions, okay? I mean, this is obviously wrong because any number can be divided in half. Now, and of course, excuse me, Heath would have been able to realize this if he had just considered that definition in the context of others. The next one says, and an odd, and there's no word and there in Greek again, and an odd number is one which cannot be divided in half, which is also false, or which differs from an even number by unit, or 1. So again, as in the previous definition, Heath misunderstands the use of the word díχα, which means to fork into equal parts. So what is an odd number, basically? An odd number is one which is not divisible by 2, right? So we could say the correct definition here is an odd number is a number that is not measured by 2. There you go. As simple as that. So I'm making these notes as I'm going along with you, so that ultimately when I revise this document, once we finish Book 7, I'll upload a free version for you to have all the definitions and propositions in one place altogether. All right, so that was definition 7. Definition 8 says an even times even. Now, this is not what is said in the Greek. An even times even number is one measured by an even number according to an even number. It's very, very confusing. So he says in his remarks, in other words, this even times even number is a product of 2 even numbers. Now, it's not good to say even times even. A better expression would be even measures even, okay? Because there's no product going on here. And the word Αρτιος can mean full or whole in Greek. And all that definition 8 tells us is that this kind of number, when divided by 2, yields an even number. Once again, if Heath had read the following definitions and looked at everything in context, he would have understood this, right? So contrast definition 8 with definition 9, which tells us even measures odd is a number when divided by 2 yields an odd number, okay? So it's surprising that Heath missed all this context. And of course, definition 10 is about the odd measures, odd numbers. That is, odd numbers that are measured or divisible by odd numbers. So I think I'm going to stop here now. I'm not going to do definition 11. I'll leave that for next time. But, okay, I've been criticizing Heath's translation, and that doesn't mean that I don't respect what Heath did. I think he did a great job, but also at the same time, his efforts fell so far short that those who studied or read his book never actually understood the elements. And it takes an absolute genius like myself to reveal these things to you. Okay, because not even mainstream Greek mathematics academics have my knowledge of Euclid's elements, and they know Greek far better than I do. It's quite possible that even Heath knew Greek better than I did, but their understanding was nowhere near as good as mine. So I'm going to continue with this in the next video, but in the meantime, if you're not a subscriber, become a subscriber and click like and spread the news of this channel so that more people can learn this wonderful knowledge, and they can learn that Euclid's Elements is a template for valid systematic thought. It's not about constructions. It's not about geometry. If anything, it's about establishing the queen of all sciences, the science of measure. Okay, mathematics is the science of number and measure, and we see this coming together beautifully in Book 7 as we continue to study how we transition from the measure of geometric ratio to algebra via the abstract unit. My name is John Gabriel. This is the New Calculus channel. Till next time, goodbye.